we have to find out the depth of flow by giving the width of the channel is 25 meters. B is equal to 25 meters is given, and from the previous problem the data that was given S is equal to 1. So the wetted perimeter P is equal to B plus 2 root 2 Y. We have to calculate this Y. The B is given. P is unknown. So for Lacy's theory, P is equal to 4.75 root Q, that is equal to 4.75 root 40. That implies 30.04 meters is the weighted perimeter. By substituting these value in the above equation, we will get B 25 plus 2 root 2 Y is equal to 30.04 meters. From this, the Y is going to be 1.782 meters. 1.782, option C is correct. Is for a reinforced concrete beam as shown in the figure. From the figure, we know that the width of the beam is 300 mm and depth is 600 mm. So the effective depth is 550. The clear cover is 50 mm. Here the number of bars that was shown over here for 20 mm diabars, to 16 mm diabars, to 12 mm diabars. And for the design M20 grade concrete was used. So FCK is equal to 20 Newton per millimeter square, and Fe415 steel is used. So Fy is equal to 415 Newton per millimeter square. We and what we have to find out, how much of area of steel is required for the beam if the depth of neutral axis is same as the maximum depth of neutral axis. AST we have to find out, and from the question that was given as XU limit, XU max, the depth of neutral axis is same as the maximum depth of neutral axis. Depth of neutral axis is same as the maximum depth of neutral axis. From this we know that maximum depth of neutral axis for this type of steel is 0.48 D, that is equal to 0.48 into 550 millimeters is equal to 263.45 millimeters. From the equilibrium of balanced section, we know that AST required, we can say, is equal to 0.36 B into FCKXU by 0.87 Fy. By substituting the above values in this equation, 0.36, 300 width into 20 into XU max is 263.45 from this figure is divided by 0.87 into 415, that is Fy, that is equal to 1576.10 millimeter square. So the relevant option B is correct. We have to find out the moment of resistance of the same beam that was given in the previous question. For a condition that area of steel that is provided is same as that of the steel required to make the depth of neutral axis same as the maximum depth of neutral axis possible for the beam, that is balanced section. So for a balanced section, the moment of resistance is given by 0.87 Fy into AST into D minus 0.42 x U max, that is equal to 0.87 Fy, we know 415 into area of the steel that is required from the previous question 1576 mm square into D is effective depth 550, we know 0.42 XU max, that is 263.45 from the previous question. The value is 249997221.4. From these, 3 digits for going for Newton in terms of kilonewton, 3 digits for millimeter to meter. So 249.99, it is approximately 250 kilonewton meter is answer. So option A is correct. This question we have to find out the bulk density of the soil. The question is, we know bulk density. Bulk density is, if we say gamma B, weight by volume, weight of the soil by volume of the soil. From the question we know that the core cutter 12 centimeter high and 10 centimeter in diameter. From this we can find out the volume of the mold, that is 5 by 4 d square is 0.1 or 10 centimeters, 10 centimeter square into height is 12 centimeter. This is volume. Weight of the soil we have to find out. In this question the sample having a mass of 1050 grams. This is of weight of mold. Weight of mold is 1050 grams. And when empty, it is used to determine the in situ density of an embankment. The mass of coconut full of soil is 3 kgs. Mass of soil plus mass of empty mold is 3000 grams. So mass of soil, that is weight of soil, is 3000 minus 1050 grams. So weight of the soil, that is 3000 minus 1050 grams by volume of the sample is going to give 2.069 grams per cc. So here option B is correct. To find out the dry density of the same soil, we know the water content is 8%, that is 0.08. So we know gamma D is equal to gamma by 1 plus W. That implies, similarly, in terms of mass, we can say rho 2 is equal to rho by 1 plus W. From the previous question, we came to know rho is 1.2.069. So by substituting the values over here, 2.069 by 1 plus 0.08, that implies 1.916 grams per cc. We know in terms of unit weight, we have to tell this in terms of weight. Gamma D is equal to rho D by rho W into gamma W. That implies 1.916 by 1 gram per cc into 9.81 kilonewton per cubic meter. So this gram per cc is going to cancel and it will come to 18.796 kilonewton per cubic meter. So option D is correct.